I hope these practice problems will help you with translating linear functions. If you will, please pause the video and start by putting this formula or equation onto your paper in your notebook, and I'm going to identify what these pieces or what these letters do to a normal graph. So first of all, we're going to look at the K. And if this is a positive or we are adding, then that means that you are going to shift up. And if it's a negative or a minus K, that means you move down. The H, this is always a minus H, and so whatever is in here, it's the opposite of what you would think. So if it's a plus, you're going to move left, and if it's a minus, you're going to move right. Due to that negative or minus here, it's opposite of what you would think. This is your horizontal movement. This is your vertical movement, up and down. So then we have the A, and there's a couple of things that happen with A. First of all, if that number is a fraction that's less than 1. So in other words, be careful for fractions like 3/2 or 5/2 or something. Those aren't less than 1. So if it's a fraction less than 1, then it's going to get flatter. The line is going to flatten out. It's not going to be as steep. It's going to compress vertically. There are several different ways you can say it, but usually it's easier to just say it gets flatter. And then if it's a whole number greater than 1, like 2, 3, 4, 5, and so forth, it's going to get steeper. It's going to get closer to the y-axis. The line is going to go, it's going to stretch vertically, sometimes the way it's pronounced. And the bigger the number, the steeper it is. Then also, whatever's in front of that, if it's a negative, if you put a negative in front of it, it's going to flip over the x-axis or the y-axis, depending on if it's in the inside or the outside. So if the negative is on the outside of the parentheses, you flip over the x-axis. And if it's on the inside, you're flipping over the y-axis. So it's a flip, that negative in front of the A. So we're going to do a couple of examples. Again, pause if you need to get all that information for all those numbers, and refer back to that when you're answering these questions. So here's your original for number 1, f of x equals x plus 3. That's just a normal line. So what we're going to do to that is we're going to take f of x, this normal line, and move it down 5 places. So this is what happens. We take the f of x here, and then to move down 5, if you go back up here, down means to subtract at the end. So we're going to subtract 5. So g of x is x minus 2. I just simplified this, the 3 minus the 5. The next one is we're going to take this original, 4x minus 3. We're going to move it 2 up and then also 2 right. So that means we're going to take g of x, and we're going to take the 4, which is on the outside, and I'm going to do this part first. The 2 right means I have to, on my x, I have to go 2 right, which is a minus 2. Remember, right is a minus. And then go ahead and keep that minus 3 normal, but then the 2 up means I'm going to add 2 to it as well. So this is what's going to happen now. We're going to distribute and solve it. So g of x equals 4x minus 8 minus 3 plus 2. So g of x equals 4x minus 9. That's after the move. Okay, number 3. Here's our original. We're going to vertically stretch it by 2, get it steeper, and then we're going to flip it over the x-axis as well. So we're going to take g of x. You have your original. 2x plus 3. But since we're stretching it by a factor of 2, we have a 2 here as your factor, and then we're flipping it over the x-axis, so we make that 2 a negative. So now distribute and simplify. That's a negative 4x minus 6. Now this one we're going to try a variety. So the first one is a vertical stretch by a factor of 2. That just means we're going to put a 2 in front of the line or the equation. And so that's going to give me g of x equals 6x minus 4. A stretch factor of 2. Put the 2 in the front. So the next one we're going to do 7 units down. So we're going to take our original. I'm just calling these g of x every time. We're going to take our original again, back up here. 3x minus 2. 7 units down means we do another minus 7 on the outside. So to simplify, that's 3x minus 9. Here we're going 2 to the left. So that's on the inside. So we're going to do g of x. 3, we're going to do an x plus 2 for left. And then don't forget the minus 2 from the original. So I put that plus 2 inside with the x. So now if I distribute and solve, that's going to be a 3x. That's going to be a plus 6, but then I'm going to subtract 2, so it's going to be a plus 4. Try to save a step. And then finally, this is a reflection over the x-axis and a stretch of a factor of 3. So my g of x is going to be, if my factor is 3, and I'm going to flip it, it's going to be a negative 3 in front of your original. So g of x ends up being negative 9x and then a plus 6. So hopefully these rules, again, focus on this. What do these things? Basically, here we have A represents a number, H represents a number, and K represents a number.